In this video, we are going to discuss about relation between the zeros and the coefficient of quadratic polynomial. Then we will solve the exercise 2.2 of Ncert textbook of mathematics class 10. Okay. So what is the relation between the zeros and the coefficients of a quadratic polynomial? Okay. This exercise is based on quadratic polynomial only. Okay. So relation between the zeros and the coefficients of a quadratic polynomial. Suppose we have a quadratic polynomial px is equal to ax square plus bx plus c, and its zeros be alpha and beta. Okay, so as we know, quadratic polynomial has two zeros. Okay, so that we have considered those two, suppose alpha and beta. Okay, then sum of the zeros, that means alpha plus beta, is given by minus b by a. So what is b here? B is the coefficient of x and a is the coefficient of x square. Okay, and product of the zeros. So how the product of the zero is related to the coefficients? Alpha into beta, that product of the zeros, is given by c by a, that is c is constant term here and a is the coefficient of x square. Okay, so let me give you an example. Okay, for example, we need to find the zeros of a polynomial, suppose x square minus 5x plus 6, and we also need to verify the relationship between the zeros and the coefficients. Okay, so first we are going to write the given polynomial. As the variable is x here, so I have written here px. Okay, so now compare this polynomial with this form ax square plus bx plus c. Okay, comparing the polynomial with this, we will get a is equal to 1, b is equal to minus 5, c is equal to 6. Here it is 6. Okay, so in order to find the zeros, we need to consider px be 0. Okay, then px is replaced by the polynomial, that is x square minus 5x plus 6. Okay, now factorize this polynomial, and factorizing this polynomial we have got x minus 3 into x minus 2. Okay, and product of them is equal to 0, that means x minus 3 is equal to 0 or x minus 2 is equal to 0. From these two we have got x is equal to 3 and x is equal to 2. That's why the zeros of this polynomial px are alpha is equal to 3 and beta is equal to 2. Okay, now let us verify the relationship between the zeros and the coefficients. Okay, so first alpha plus beta, that is sum of the zeros, is 3 plus 2. Here the zeros were 3 and 2, so we have added 3 and 2, which gives 5. Now we have to verify that, we need to verify that alpha plus beta is equal to minus b by a. Okay, minus b by a. So as we need to obtain minus b by a, so here you see, first of all we have to write here minus sign. Okay, because we need minus b by a. Okay, now let me clean this little bit. Okay, now you see, as I have written here minus sign, but it was positive, so that's why I have written again minus 5, then minus minus, it will be plus. Okay, minus minus plus. Now as you see, I have already told you that alpha plus beta, we are supposed to show that alpha plus beta is minus b by a. Okay, minus b by a. B is minus 5, we have already got this minus 5, but a is here 1, value of a is 1 here. So now you see, this 5 can be written as 5 by 1 and plus 5 can be written as minus minus 5 by 1. So 1 is replaced by a and minus 5 is replaced by b, and this minus is this one. Okay, that's why we have got minus b by a, which is equal to alpha plus beta. Okay, alpha plus beta is equal to minus b by a, hence one relation is verified. Okay, Similarly, we can verify alpha into beta is equal to C by A. How? Alpha into beta is 3 to the 6, 0 the 3 and 2. Okay, and we have got 6. Now you see value of C is 6 and 1 is A. Okay, so that's why 6 is written as 6 by 1 in order to obtain C by A. So that's how we can verify. Okay, so let us solve the problems of the exercise 2.2. Okay, so here you see this is the first question. Okay, in this exercise we need to find the zeros of these given polynomials, and also we need to verify the relationships between the zeros and the coefficients. Okay, so in order to find the zeros we have to consider px is equal to 0. Then we have to write px we have to replace the px by this polynomial which one is given. Okay, then we need to verify this polynomial, factorize this polynomial. Okay, so you know how to factorize the polynomials. Okay, now factorizing this polynomial we have got x minus 4 into x plus 2, which implies x minus 4 is equal to 0 or x plus 2 is equal to 0. So x is equal to 4, x is equal to minus 2. So 4 and minus 2 are the zeros of this polynomial. Okay, so now in order to verify the relationships, so what to do? First we have to write the zeros of the px, that means the given polynomial are alpha is equal to 4, beta is equal to minus 2. Okay, now let us verify the relation. Okay, so first sum of the zeros, that is alpha plus beta. So what are the zeros? 4 and minus 2. Okay, this is minus 2. Okay, 4 plus minus 2 means 4 minus 2, which gives 2. Okay, we need to show that alpha plus beta is equal to minus b by a. So here you see this 2 can be written as, now you see b is here minus 2, so a is 1. So in order to obtain minus b by a, this 2 can be written as, if you write minus 2 in order to obtain the b, then what will happen? One more minus should be given before it. Okay, then we will get here minus 2 and here minus and minus 2, minus again plus. As we need to find b by a, so that's why this minus 2 can be written as minus 2 by 1. Okay, so I have written minus 2 by 1. So now replace the minus 2 by b and 1 by a. So that's why we have got alpha plus beta is equal to minus b by a. So what we have got? Alpha plus beta is equal to minus b by a, hence verified. Similarly we can verify alpha into beta, that is 4 into minus 2, that is equal to minus 8. Minus 8 can be written as minus 8 by 1. Okay, and minus 8 is here the value of c and 1 is the value of a. That's why we have got c by a, hence verified. Okay, so I hope you have understood this. Similarly we can solve the remaining problems. Okay, so here you see in number 2 you can solve second of question number 1. So here you see as the variable is s here, so I have written ps instead of writing px. Okay, this is similar to the first one. Okay, let me show you the next here. So now here you see the third polynomial is given 6x square minus 3 minus 7x. So here you see first rearrange this polynomial. Okay, term consisting minus 7x right at middle. Okay, so I have rearranged this. Okay, so now compare with ax square plus bx plus c. Okay, so hope you understood this. Okay, now comparing with that we have got a is equal to 6, b is equal to minus 7, c is equal to 3. Okay, then again factorize and obtain the zeros, then verify the relationships between the zeros and coefficients. Okay, so now let me explain the next one, that is 4. Here you see 4 of question number 1. Here the polynomial is in u, that's why I have written pu, which is equal to 4u square plus 8u. Okay, here a is 4, b is 8, and here the constant term is missing, that's why c is equal to 0. Okay, that must be, we have to consider that that must be 0. Okay, so here you see, in order to obtain the 0, we have considered px is equal to 0, which is equal to, which implies a 4u square plus 8u is equal to 0, and from these two we can take 4u common. On taking 4u common, we have got here u plus 2. So as their product is equal to 0, so we can write either 4u is equal to 0 or u is equal to 0. Sorry, 4u is equal to 0 or u plus 2 is equal to 0. And dividing, now here you see, dividing both side by 4, we have got u is equal to 0. Okay, so now u plus 2 is equal to 0, which implies u is equal to minus 2. Therefore the two zeros of this polynomial are alpha is equal to 0, beta is equal to minus 2. Okay, then let us verify this relationship. Alpha plus beta is equal to, here 0 plus minus 2, which is equal to minus 2. And as you see, we need to obtain alpha plus beta is equal to minus b by a, minus b by a. So here b is 8. Okay, b is 8. So how to obtain the 8 minus 8 from 8 from minus 2? First multiply 4 here, then again divide it by 4. When you cancel 4 and 4, then again you will get minus 2, isn't it? So why we have done this? Because we need to obtain here 8. Okay, 2 4s are 8, and here it is 4, and this is the minus, this minus is this one. Okay, so now you see, from here we have to replace the 8 by b and 4 by a. Okay, this minus is here, so we have got minus b by a. So the relation is verified. Okay, so similarly we can verify that product of the two zeros, that is alpha into beta, is also equal to c by a. Okay, so alpha into beta, that is 0 into minus 2, which is equal to 0. So here c is 0 and a is 4, so we can write 0 by 4 as 0 can be written as 0 by 4. 0 divided by anything is 0 again, so c by a we have got here verified. Okay, so similarly we can solve the remaining problems also. Okay, here you see the next one is t square minus 15. Okay, and here you see 15 minus 15 is the constant term. Okay, and t square is there, so there is nothing, means 1, so a is 1, and the term consisting only t is not there, that's why b must be equal to 0. Okay, and so again, like the previous one, consider pt is equal to 0, so t square minus 15 is equal to 0, which implies t square equal to 15, so t will be plus minus root 15. So there are two roots, one is plus root 15, another is minus root 15. Okay, then we can verify the relationships like this. Okay, so let's move on to next topic. Okay, and one more problem left here, that is 6 of question number 1. So this is the last one. Okay, I'm not going to explain this. I hope you have understood, and now you can solve by yourself. So if you want to note the problems, okay, then pause the video wherever, whatever you note. Okay, so now next topic is how to find a quadratic polynomial if the sum of the zeros and product of the zeros are given. Okay, so there are two methods. First one is, if the sum and zeros of the product sum and product of the zeros given, okay, we can obtain first the corresponding quadratic equation. Now you see, so this is the form of quadratic polynomial ax square plus bx plus c. Okay, if you write here equal to 0, then it becomes quadratic polynomial. So first we will obtain this quadratic when you write bx plus c is equal to 0, then this is not a polynomial, now it is equation. Okay, so if you don't write this part, then only if you write this part, then you can say it is polynomial. Okay, now you see, first let us obtain the corresponding quadratic equation. Okay, so how to obtain that? X square minus sum of the zeros plus product of the zeros equal to 0. Okay, so for example, I have given, so here you see this sum and product of the zeros of a quadratic polynomial. Polynomial is not given, we need to determine the polynomial. So respectively are half and minus 1. So half is the sum of the zeros, minus 1 is the product of the zero. Okay, so put half here and put minus 1 here. Okay, then you will obtain this corresponding quadratic equation, that is x square minus half x plus minus 1 is equal to 0, which implies x square minus x by 2 minus 1 is equal to 0. Now in order to cancel this 2, okay, let's multiply both side by 2. Okay, then what will happen? Twice x square minus x and minus 2 is equal to 0. This is corresponding quadratic equation, and this part is the polynomial. Required polynomial is twice x square minus x minus 2. So there is another method, let me show you. Okay, if the sum and product of a polynomial are given, then how to find the polynomial? So this is one method, and another method is this. So I have written here, or let, here we need to assume the polynomial first. So px is equal to ax square plus bx plus c. Here sum of the zeros is given, that is half, and we know that sum of the zeros is given by minus b by a. Okay, and also given product of the zeros, that is equal to minus 1, and product of the zero is c by a, which is equal to minus 1 here. So in both cases you see product of the 0 and sum of the 0, here denominators are a. Okay, in both cases. So on the left hand side, as the denominators are equal, so we need to make the denominators equal on the right hand side also. Okay, here is the denominator is 2, and this is minus 1 by 1 you can consider. So in order to make this one also 2, we have multiplied 2 with both the numerator and denominator. That's why here we have got minus 2 by 2. Now you see, in these two cases denominators are same. Okay, so we can consider a is equal to 2, that's why. And here b will be equal to minus 1. Why? As we have considered a is equal to 2 here. Okay, a is equal to 2, then we have got minus b and 1 here, numerator is 1. So if minus b is equal to plus 1, then definitely plus b will be minus 1. Okay, so and c is equal to minus 2. Okay, so now put these values of a, b and c, put these values of a, b and c in this polynomial, then you will get the required polynomial, that is twice x square minus x minus 2. Okay, so now let us solve the questions, question number 2 of exercise 2.2. Okay, so this is the first question of question number 2. So here let us assume, or let us consider the polynomial is px is equal to ax square plus bx. Okay, this one be the required polynomial whose zeros are alpha and beta, such that it is given sum of the zeros is given, that is alpha plus beta is equal to 1 by 4, it is given. Okay, I have not written the question, I think you have the book, so that's why I am not writing the question here. And product of the zeros, alpha into beta, is minus 1. Okay, now you see alpha plus beta, that is sum of the zeros, is minus b by a, and product of the zeros c by a. So here is the, here you see denominator is 4, and as on the left hand side in both cases denominators is a, so that's why on the right hand side also, if there is 4 is the denominator, then let us make here 4. Okay, in order to do that we have to multiply 4 here, and with the denominator as well. So if you cancel 4 and 4, then you will get again -1. Okay, so now you see -1 into 4, that is -4. And now compare these two, and comparing these two we can get a is equal to 4. Okay, so here is the denominator a, here is also denominator a. On the right hand side, denominators is are 4 in each. Okay, so we can consider a is equal to 4. Then minus b is equal to 1, so b will be -1, and c is equal to -4. Okay, and putting these values of a, b, c here, we have got the required polynomial, that is 4x square minus x minus 4. Okay, similarly you can solve the remaining problems. Okay, I have already shown you two examples, and one example and one question. And there was I have already mentioned about another method, that was what, finding the corresponding quadratic equation. You can obtain the quadratic polynomial. Okay, so sum of the zeros, alpha plus beta 1/4 alpha into beta -1. Okay, so x square minus sum of the zeros, that is alpha plus beta, into x, product of the zeros, that is alpha into beta. Okay, so put the value of alpha plus beta here and put the value of alpha into beta here, then you will obtain x square minus 1/4x plus -1. So now in order to make this 4 cancel, what to do, we have to multiply both side by 4. Okay, multiply both side by 4 here and here. Okay, then doing so we have got 4x square minus x minus 4 is equal to 0. So only this left hand side is the required polynomial. Okay, that's how we can solve. This is another method. Okay, so similarly you can solve the remaining problems of question number 2. So this is 3 of 2, this is 4 of 2, and this is 5 of 2, and this is the 2 of 2. Okay, and if you want to note those problems, you can pause the video right here, and this is the last one of question number 2. Okay, and let me discuss one more thing, that is what, how to find the quadratic polynomial. How to find a quadratic polynomial if its zeros are given, not the sum of the zeros and product of the zeros, zeros are given, alpha and beta. Then again we will find a corresponding quadratic equation. This is quadratic equation, that is what, x square minus alpha plus beta into x, plus alpha into beta. Okay, so for example, suppose we have taken suppose we need to find the quadratic polynomial whose zeros are -12 and +1. Okay, these are the zeros, not the product of the zero and sum of the zero and product of the zeros. Okay, these are the zeros directly. So alpha is equal to -12 and beta is equal to 1. Now put this value of alpha and beta here. Okay, then putting those values here, we have got x square minus -12 plus 1, which is again half in here, we will get -12x. Then -12 into +1 is -12, again minus plus minus, so here we will get -12. Okay, so now the polynomial will be obtained after cancelling these 2's. Okay, so let's multiply both sides by 2. Okay, then doing so we have got 2x square minus x minus 1 is equal to 0, and the right hand side, not the right hand side, left hand side is the required polynomial. That's how we can solve such kind of problems if the only the zeros are given. Okay, so hope you have understood. So I have completely solved this exercise 2.2. Okay, thank you for watching.